That's what happened to my previously built rocket motor. And this is what happened to my first attempt at building a rocket motor. But the main question is, why did both attempts fail? Was it because of the fuel or the building process? But as I promised not to give up, I tried for a third attempt. After learning from my failures and gathering information from your comments, I built a rocket motor again. But did it work? Just stick with this video, and you will find the answer very soon. The first step in building is to prepare the nozzle, as always. If you watched my previous video, you already know that I used adhesive clay to make both the nozzle and the end cap. But this time, I dropped that idea and started over again. So, I took some regular clay and mixed it with cement powder. But why this change? I could have easily used the adhesive clay. It's solid, durable, and easy to work with. However, if you know a little about rocket motors, you'd know that rocket exhaust can reach temperatures of 1300 degrees Celsius to 1700 degrees Celsius, more than enough to melt aluminum. My off-camera experiment showed that the adhesive clay started melting just seconds after the motor was ignited. That alone is reason enough to abandon the idea of using adhesive clay. Before packing the clay, I scraped the inner surface of the rocket body to create a strong bond between the clay and the surface. During my first attempt, I accidentally broke some pieces of clay while making the hole for the nozzle. It looked quite bad, so I decided to remove the clay from inside the tube and start again. The bond between the clay and the surface was so strong that I wasn't able to remove it, even with a hammer. I had to scrape the clay off the surface. But that's actually a good sign because such a strong bond is necessary to withstand the pressure inside. The nozzle is ready and looks very clean. Now, I had to leave it in the sunlight to dry completely. While the nozzle is drying, let's talk about my past builds. One of those builds is this. I made this motor about 2 years ago using just some PVC pipe. I know it looks terrible, but I had no experience at that time. Not that I have much experience now either. It was a fully functional rocket motor, as you can see. The nozzle, end cap, and body could be easily disassembled. I was using rocket candy fuel for this motor, as many of you still suggest I should. You can clearly see that I did a decent job making the fuel grain, which is probably why this motor didn't produce any power. To everyone suggesting I should use sugar fuel, I'm not going back to it because I just don't like it. It's messy, sticky, and doesn't have a good shelf life. Plus, it's extremely hygroscopic, which makes it unreliable over time. I've already flown a few small rocket motors using sugar fuel in the past, and I'm done with it now. I'm looking for something better. I even have another clip where I was testing a sugar fuel motor from 2 years ago.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
I don't know what's going wrong with my rocket motor builds. But one thing I do know, I won't give up. The nozzle is completely dry now. Let's move on to the next step. I don't think I would do that. But once again, I chose black powder as the fuel. This decision is kind of dumb because I already know that using this propellant is a losing game for me. At that point, I completely ignored everything I had learned from my past experiences. Some of you suggested that I use rocket candy or sugar fuel, but instead of that, I plan to create a fuel that would be better than sugar fuel and less reactive than black powder in the future. Right now, I have to use BP for this motor. I just hope it won't turn into a bomb again. The process of packing the fuel is the same, but this time, I didn't add water like in the last build. I just mixed BP with hand sanitizer, which contains alcohol. You guys also suggested that I should not make a long core inside the motor, because the larger the surface area, the faster the fuel burns. And since black powder already has a high burn rate, making a long core would likely cause it to explode. Considering these factors, I decided to make a core that extends only halfway through the length of the grain. This will reduce the surface area and lower the risk of an explosion. I placed the motor in the sunlight to dry completely. While waiting, I started preparing a long wire for the ignition system, because the wire I used to ignite the last rocket motor was too short, and standing near a rocket isn't a good idea. To make a longer wire, I found some old decorative lights lying around the house. It took me nearly an hour to extract all the wire I needed, which was quite difficult because the wires were tangled together. After that, I ended up with a very long wire, allowing me to ignite my rocket motor safely. The only step remaining is to prepare the end cap. I placed a piece of paper over the fuel grain and then packed everything with a mixture of clay and cement. The motor is now ready to be tested after absorbing some sunlight. Let's move forward, and I will see you at the test field. My friends helped me set up, and we were using a metal tube as a stand for the motor. There was no one nearby, which means we could safely fire the motor. We put the igniter in, unwound the wire, and let it go.
एक दो तीन
I failed for the third time now. Choosing black powder was a poor decision. I thought it would work perfectly, even after reducing the surface area. This build taught me that a high burn rate propellant, like black powder, can't be used in small rocket motors. Now I will try to develop another type of fuel that is stable enough for safe use. If you're new here, go check out my other rocket build videos to understand what's happening and what's coming next. I'll see you again in my future videos.